Soliddd DDD, or I guess Soliddd DD. Tell us about this new technology you've created. I recently had the pleasure of seeing it for the first time recently. I know that your licensee, Lenticular Europe, Jake Purchase, is the official European licensee, I think. And he showed me a fantastic poster. And also, I believe one will be, I think the very first UK will be in an art gallery pretty soon. And it looked sensational, and I guess the first thing that really I particularly noticed was that there appeared to be a greater sense of depth. So perhaps you could start off by telling us why this is different to other lenticular imagery that we've seen before.
Yeah, well, basically because Richard Muller, who's our CTO and one of the most brilliant physicists in the world, has figured out the optics of auto stereo. And I've been working and trying to develop auto stereo displays for a couple of years with a crew of engineers. And I wasn't happy with what we were able to produce yet. And I was introduced to Rich, explained to him all the problems that I had seen as insoluble at that point. And this was in the course of a first, about 2-hour phone call that I had with him. And a month later, he called me back, and he'd solved most of the problems. And in the course of so doing, came to what he called the Soliddd equation. And because I had just named the company Soliddd, we were actually pursuing a 3D camera system, which is a very exciting system, but is not as exciting as solving the problem of auto stereo display. So anyway, the Soliddd equation is a way for us to just plug in values and create lenses doing exactly what we want, and with a full understanding of the optics. Now, having achieved that, we set about to make some lenses based on our math, and pretty quickly discovered that the other lenses that have been out there in the world have been highly inaccurate. And even, for what they're trying to do, nobody realized just how good auto stereo displays can be, and therefore no one was even trying to manufacture as accurately as they really should be doing, because they didn't know what they were doing. But anyway, so we're manufacturing this stuff with extreme accuracy, and we have a full sense of the optics we want to achieve, and we can achieve any depth that we want, any viewing angle that we want. It's all a matter of plugging values into the equation. You can't do everything from every point of view. So I don't know if Jake, for instance, showed you our newest lens that is meant for close viewing. And there you get several inches of depth from something you can just hold a few inches away from your eyes. And Jake has produced some gorgeous images to go along with that lens. And that, of course, is a different lens than what you would use for large-scale posters on the street.
I didn't see the close-up one. The one I saw, I think it was a chicken nugget, actually, a giant chicken nugget.
Yeah.
And it had sort of positive and negative parallax. So you're saying that, there was a huge amount of depth in the one I saw, but you say you can push it even further, potentially, are you saying?
Oh, absolutely. And for street posters, we think a good amount of depth. Something like a 6 sheet, which we're just working on with some potential customers, would be 5 feet of depth, including about 2.5 feet of negative and 2.5 feet of positive parallax. The poster you saw had about 30 inches of depth at maximum, and that is another. I think Jake would have showed you perhaps some other pictures that he has for a newer version of that basic lens design that we've made a bit more accurate, and he should have some very nice pictures. I don't know if he showed them to you or not.
Sure. The one I saw that's going up in the exhibition in London, I think that was made out of a glass frame or lens, not quite sure, that it was sort of even better. I'm guessing that was more it's sort of more of a permanent install. But I think one of the most unique things that you guys have done, and I know I think that you've got the patent to this, is this RPF, this replaceable picture frame, because obviously as it stands now, if you, for example, I went to Pearl and Dean recently, and I used to work at a cinema myself, and I remember part of my job was to always replace those pictures, and of course you have the standard box, and then you just replace very cheap posters you get from the distributor. So you've got a solution now where rather than having a image adhered to a frame, a lens, you can replace that, right?
Exactly. If you understand the optics and you make a very accurate lens, then you get some benefits that we hadn't really realized when we were first starting. One of those benefits is that you can achieve air gap pictures, which people have been able to do for quite some time on a one-off basis, but not reliably in a volume manufacturing kind of basis. So we're so accurate that the printer doesn't have to align and calibrate every individual print or every few prints to a slightly different setting for different lenses, which is the normal way of operating now with lenticulars. And because the print is accurate to the lens, which is routinely accurate, then aligning these pictures becomes very easy. And we can have the lenses sitting permanently in a frame and put the pictures easily in and out in back of the lens. That means that in posters in the cinema you could do it. It also means you could have replaceable picture frames for sale at five and dime stores, and people can just have their photos converted to auto stereo 3D and place their photos behind a lens.
And have you managed to the issue with I know you don't particularly call it lenticular, well certainly what Jake called me, you just sort of refer it to the Soliddd system, but have you managed to improve the viewing cone issue? Because I found that the viewing cone was great. I mean, especially the one I saw that I stood back, I guess about 4 meters away. So have you also managed to improve that situation that's inherent with regular lenticular pictures?
Well, first, a couple of small corrections. We pronounce our name Solid. You don't have to say Soliddd.
Oh, okay.
And second, and you may know that, you know what the word solid means in Greek, by the way?
I don't actually know.
It means stereo.
Oh,
so,
okay.
In any case, these are lenticulars. So I have nothing against using the word lenticular about the lenses that we're making, but they're just highly designed lenticulars. We've taken the basic idea of a lenticular, which was thought of perhaps 100 years ago, and refined it with accurate optics. There's nothing wrong with calling it a lenticular. But in any case, and now the crux of your question, I've forgotten already.
Well, with regard to viewing cones, okay. have you managed to widen those viewing cones of this?
Yeah, we made a arbitrary choice to have a 10% 10 degree viewing angle, and that 10 degrees would repeat several times across the overall viewing cone. The overall viewing cone, we decided, again, somewhat arbitrarily, should tend to lose 3D at about an overall angle of 100 to 120 degrees. That is up to 60 degrees off axis. If people are looking from the extreme side, they're not going to see an accurate 3D picture anyway. Also, the 10 degree decision is an arbitrary one based on the fact that that's about all the ability to look around objects in depth that you're likely to get from motion pictures. And that's what we've really been aiming for from the beginning. And in general, we've thought that we want to make the still image display something that's compatible with getting images out of video. Now, we could change that. And there may be reasons, I can think of several reasons why people in various kinds of signage situations would want a wider arc section for the overall picture. If you have a too wide, then the people on the right-hand side of the picture are seeing something different from the people on the left-hand side of the picture, as if you're in a live theater instead of in a movie theater. But people may want that. And there's nothing wrong with that. We're technologists, and we want to make these products so that artists can make the best use of them. So if an advertising agency or a fine artist came to us and said, yeah, here's my concept, then we would design a lens specifically for it. And we can design these lenses in seconds. It's just a matter of plugging values into the equation.
I mean, I understand you can print these images on paper and vinyl, and so you're not restricted there. So, let's say, in terms of, I mean, I know a fair bit about sort of lenticular technology. I went to, I don't know if you're aware of a company called Triaxis, who are based in Siberia, and I'm very familiar with their 3D master kit and all these things. So, in terms of the general language and terminology, in terms of LPIs and using the degree of lenses and things like that, how compatible is it with Soliddd? So, for example, could I create a picture that would be compatible with a Soliddd box, for example, or is this a proprietary coding system where you would have to do the encoding? What is your sort of business model? Is that part of your business model?
We like the idea of lots of people being able to make art for what we do. We're in the business of selling lenses and replaceable picture frames, and whatever kind of art people want to do for that is fine by us. Now, we also have some really great software that we've been working with that can convert from various kinds of original images, the best being left-right stereo video. But even from still images with some work. And we want to enable people to, put whatever kind of content they can behind these lenses and in these replaceable picture frames. So the answer to your question basically is yes. And it's in terms of the creation of the art, it's not all that different from creating art that you may have already done for other people's lenticulars. It's just that we get much better depth, much better viewing angles, and much better focus as well, along with the depth. And one of the things I'm really, really proud of is that we're getting just tremendously accurate focus with this close viewing lens. So this can be something that could be on pages of a book, the cover of a book, and you'll read very, very fine pica type, where you simply can't see that stuff with any normal lens, and that,
absolutely, yeah.
We've got a different shape to the lens. It's a patented shape, and so even the old terminology and the way of thinking that you would want to have a finer grain LPI, more lenticles per inch, to be able to have finer focus, doesn't actually apply in the same way, and it applies to some extent, but then there's too many trade-offs for doing that and not being able to get the depth that you might want with that. So there's a lot of confusion that people have had about how to achieve the goals of greater depth with focal accuracy and so on in lenticulars up until now. And I just thank my lucky stars. If I have any claim to fame, it'll be as the guy who brought Rich Muller to just have a crack at the problem of autostereo 3D. He solved these things.
I mean, but just a very quick point with that. So I'm just sort of, let's say that a company sort of licensed out the boxes. How would somebody then make compatible images for you? Will you be creating, for example, a Soliddd plugin for other lenticular design packages? Because usually, obviously, you have to know the pitch and you have to know the LPI and the degree of lens, and you put it all in, put those values in, and then therefore you're printing the correct image. Would you need something else to ensure the compatibility with a Soliddd box and lens?
We'd have to look at each of the design systems one after another and see if they're doing things right enough to work with what we do. We have looked at a couple of software packages so far, and there's pluses and minuses. So I think we have to go to the software companies one at a time and talk to them about how they could let's say enable a Soliddd plugin or upgrade their software and so on and so forth. We're in discussions with a couple of those companies, and I really can't say anything more about that.
Sure. Obviously, lenticular, it's not just about 3D. You've got things like motion. I mean, I think you can go almost up to, is it 25 frames or something? So could you potentially create sort of some fantastic, 1 second of video maybe if you walk past the image? I'm thinking, for example, on the London Underground, I think CBS Outdoor run that account, and they've got a few of these motion images now. So you're looking to go into that as well?
Yeah, absolutely. There's we have that capability as well, and we're typically doing many more views than other people have done. I think you'll commonly see something like 8 or 9 views at the most. I've seen some lenticulars that have been produced in reasonably high numbers with 16 views. Then you get real just bespoke efforts, just a few units made with perhaps 32 views. So, for instance, on the closed viewing lens, we've got typically 60 views that we're doing right now on our demos, and we can do many more. And any of those views, or let's say the sum total of those views, can be used for movement as well as for depth. You can have both movement and depth. You don't have to sacrifice depth for movement or vice versa.
And you're the only ones you can offer, because I certainly haven't seen anything like it. I saw it I think it was 2 weeks ago, and the people we showed were blown away. I mean, they've seen a lot, and they hadn't seen anything like it. They acknowledged it was certainly the best they'd seen, and sort of they said, "Oh, can we have this exclusively?" and things like this. So, being in that quite fantastic position where you have the patent to the sort of new technology, how do you intend to span this out? Do you have clear markets that you're going to target? Are you sort of looking at advertising agencies at the moment, or what's your sort of 2 or 3 year plan to get this across the globe? If you can say that in a few minutes, I don't know. Probably not.
I don't know if I have a full 2 or 3 year plan. I mean, we have a lot of options. We're a new company. We're introducing ourselves to the world now. Next week at Advertising Week, a conference in New York City, here where I am, and we'll show a number of pictures and advertisements made by people who are starting to use the technology. We're working on several deals. We're looking to just sell our lenticulars and replaceable picture frames to pictures to printers and to people that are interested in having all kinds of businesses with it. So that's,
I'd like to just...
I don't have a plan for world domination, no.
I'd just like to sort of wrap up really with I mean, for example, 3D auto stereo televisions use quite similar principles to lenticular. I mean, they do use lenticular panels, so it's quite exciting to think about how your system could potentially be used in the future for televisions. Is that something even conceivable? Okay,
you're right that lenticulars are typically on the surface of the screen in most attempts at auto stereo TV. Not always. There's a lot of them that are parallax barrier. But some are lenticular. People tend to be using lenticulars more for larger scale images, and the smaller ones, tablet size and smaller, are parallax barrier. But we firmly believe that the lenticular belongs even on very small displays. But the problem with displays small and large is that you need a lot of pixels for 3D, and you need even more for auto stereo 3D than for 2-view 3D. The more views you have, the more pixels you need. So there's a couple of key innovations that we've patented that extend the available pixel count, and we think that those are perhaps even more serious intellectual property than our patents on the solid equation and the lenses. And so we think we can multiplex pixels by a factor of between 3 and 12 or even more. And that's what we're working on in our prototypes, and I hope you'll see results in several months.
Fantastic. Well, I really appreciate that. It's Soliddd, so it's SOLIDDD.com. You have lots more information on that as well, don't you? So thank you very much.